Have you ever wondered if everything you perceive in this three-dimensional world might be an illusion? A mind-bending question, isn't it? Welcome to the fascinating realm of theoretical physics, where we're about to delve into an idea that will challenge your understanding of reality, the holographic principle. Imagine a world where all the information and physics within a three-dimensional space can be equivalently encoded on a two-dimensional surface. It's a paradoxical concept, yes, but it's the very crux of the holographic principle. This revolutionary theory suggests that our entire universe, in all its three-dimensional glory, might be nothing more than a holographic projection, a sophisticated illusion derived from data stored on the surface of space itself. But where did this groundbreaking theory originate, and who are the minds behind it? To unravel this mystery, we need to journey back to the seminal work of two remarkable physicists. The genesis of this mind-bending idea can be traced back to Gerard 't Hooft and Leonard Susskind in the 1990s. These two physicists, undeterred by the complex enigma of the universe, delved deep into the study of black holes. Their goal? To unravel the mysteries of black hole entropy and event horizons. Let's take a step back and understand these terms. Black hole entropy is a measure of the information content within a black hole. Event horizons, on the other hand, are the theoretical boundaries beyond which nothing escapes from the gravitational pull of the black hole, not even light. Now, armed with this understanding, let's follow 't Hooft and Susskind on their exploratory journey. They set about conducting a series of thought experiments and calculations which gradually began to reveal a remarkable connection between black holes and information theory. The crux of their work revolved around a profound revelation. The entropy of a black hole is directly proportional to the surface area of its event horizon, not the volume it occupies. This was revolutionary. It was a stark departure from our conventional understanding of physics. It suggested that the entire three-dimensional properties of a black hole, its volume and contents, could be entirely described by the information residing on its two-dimensional event horizon. Imagine that, a seemingly infinite three-dimensional black hole, encapsulated by a mere two-dimensional surface. It was as though they had stumbled upon a cosmic magic trick. But this was no trick. It was a groundbreaking discovery that challenged the very foundation of our understanding of the universe. Their work led to the birth of the holographic principle, a principle that suggested a paradox, that our three-dimensional universe might just be a projection from data stored on the two-dimensional surface of space. Their astonishing revelation was that the properties of a black hole could be entirely described by the information residing on its two-dimensional event horizon. And so 't Hooft and Susskind became the architects of the holographic principle, forever altering the way we perceive our universe. Scene script. This groundbreaking discovery led to the concept of a holographic duality. Let's dive into this captivating concept. Imagine a puppet show. Now, in this show, the puppets are three-dimensional, moving around and interacting in a three-dimensional space, but all their actions, their stories, their very existence is controlled by the puppeteer's hands moving in a two-dimensional plane behind the scenes. This is a simple analogy for the holographic duality. In the realm of theoretical physics, the holographic duality proposes that our three-dimensional universe is akin to those puppets. All the information, the physics, the very fabric of our reality is encoded and controlled from a two-dimensional surface, much like the puppeteer's hands. This two-dimensional surface is a boundary, an event horizon that encompasses our universe. The duality part of the holographic duality comes from the idea that both the two-dimensional surface and the three-dimensional space it encodes are equally real and equally important. Neither is more real than the other. They are two sides of the same coin, two different ways of describing the same reality. This idea that information in three dimensions could be projected onto a two-dimensional surface is a bit like watching a 3D movie on a 2D screen. The screen is flat, but the images give the illusion of depth, of a third dimension. Similarly, our three-dimensional universe could be an illusion, a projection from a two-dimensional surface. But remember, this is not about reducing the reality of our world. It's about expanding our understanding of it. It's about seeing that the universe is even more fascinating, more intricate, more wonderfully complex than we could ever have imagined. This revolutionary concept of holographic duality, born from the study of black holes, has opened up an entirely new way of looking at the universe. It has challenged our understanding of reality and has given us a new language to describe the cosmos. But the implications of this principle go far beyond our understanding of black holes. The holographic principle opened up a Pandora's box of profound questions and exciting possibilities. Indeed, the implications of this concept stretch far beyond the celestial abyss of black holes. It compels us to reevaluate our understanding of reality and the universe we inhabit. The holographic principle provides a fresh perspective in physics, cosmology, and philosophy, pushing the boundaries of our comprehension. In physics, the idea that our three-dimensional world might be a projection of information on a two-dimensional surface challenges the traditional laws of physics. It suggests that the fundamental building blocks of our reality might not be particles or strings, but rather information itself. If this is true, then it is a groundbreaking shift in how we perceive and study the physical world. In cosmology, the principle proposes a new way to understand the universe. If we are living in a hologram, then the Big Bang, the expansion of the universe, and even the existence of dark matter and dark energy could all be reinterpretations of two-dimensional information on the boundary of the universe. This could potentially revolutionize our approach to unraveling the mysteries of the cosmos. In philosophy, the holographic principle stirs up fascinating questions about the nature of existence and reality. If the universe is indeed a hologram, what does that mean for our sense of self and consciousness? Are we too nothing more than intricate holograms projected from the edge of the universe? To summarize, the holographic principle is a radical idea that suggests our universe may be a sophisticated illusion, a holographic projection from the surface of space. It challenges our understanding of reality, proposing that all we perceive in three dimensions could be encoded on a two-dimensional surface. It's a concept that invites more questions than it answers, opening up new avenues for exploration and discovery. So the next time you look at the stars, remember, you might just be looking at a sophisticated illusion, a holographic projection from the edge of the universe.